This form takes the single stage step-in metabolics and adds to it a multi-stage metabolic assessment of the step-in. So this one is the same as the single stage, so you can use this form or you can use the single stage one. It's the same calculations. Let's go down here, and we're going to put the step height at 16 inches, and we're going to look at the person over 3 different values. We're going to start them at a pace of 22 steps per minute, and that would be 88 on the metronome. So if you've got a metronome, you can set it to 88, and that'll keep them stepping at 22 steps per minute. Now you can see the MET value and the VO2 for that particular speed. Now if we want to do a VO2 test, we're going to want to also measure their heart rate at that particular intensity. So have them do this pace for a couple of minutes, and then during that second, third minute we want to be looking at what the average heart rate is. And this particular person did an average heart rate of 132 beats per minute. Now what we did then was we increased the speed from 22 steps per minute to 26 steps per minute, and you can see that that then changes the intensity values in METs and also the VO2. And after 2 minutes of step-in, we measured the person's steady state heart rate or average heart rate, and we found that it had gone up, and it was now working at about 142 beats per minute. And then we did a third stage by increasing them to 30 steps, measuring their heart rate during the second and third minute. We found that it was 151 average, and so we've got a nice little VO2 test here. And what we can do with this is we can take this information here, the heart rate, METs and VO2, and we can plug it into another form, which is the Armstrong metabolic VO2 graph, and we can then determine what a person's predicted VO2 max is given this set of data from step-in.